Okay, we'll talk about stoichiometry of gases. Really, we're just integrating some of the things we did for the stoichiometry chapter and showing that you can do the same thing and apply our gas laws to it if you're talking about reactants or products in the gas phase. Remember, you can relate moles and volumes using the stoichiometric coefficients. So in our case, we want to calculate the amount of hydrogen gas in grams and liters that could be formed when 8.5 grams of magnesium metal is completely reacted with hydrochloric acid at 24 degrees Celsius, and the current barometric pressure is 770 torr. Okay, so I've carried forward all of the information from the problem. We want to calculate the moles and then the grams of hydrogen gas from my grams of magnesium. Magnesium is 24.31 grams magnesium per 1 mole magnesium. Using the balanced reaction, we had 1 mole of magnesium to 1 mole of H2. It won't always be 1-to-1, so you need to be careful of that. And then this, I need to almost back out of the multiplication and figure out these moles because I'll need it for my gas law problem. So if I crank out the moles at that point, we get 0.350 moles of H2. That is the N in our gas law problem. Now we'll just go ahead and crank out the mass, 2.02 grams of H2 per 1 mole H2, and then we get 0.706 grams of H2 produced. That would be a result more like we get in chapter 3. But now we want to use PV equals nRT, find out the volume of gas produced. So volume is equal to nRT divided by P. Now we need to calculate that, so we're going to divide by 760 torr per ATM, and that's going to give us 1.01 ATM. Now we can plug in everything. 0.350 moles H2, or our constant 0.0821 liters ATM per mole Kelvin. Then our T is 297 Kelvin, all divided through by the pressure of 1.01 ATMs, because that's really close to 760, so you wouldn't expect it to be too far off. And we get 8.45 liters of gas. And so this was one answer, and that is the other answer that was being asked for in the problem.